Welcome to the final segment of TechMar's Snowmelt Training webinar series. In this segment, we're going to do the technical overview of the 654, and that will include looking at the mechanical diagrams for our 7 featured applications, as well as the electrical diagrams and going over all of the essential settings so that you can program the 654 accordingly for your snowmelt system. The outline for the presentation is to begin by looking at those mechanical and electrical diagrams for the 7 featured applications. After we're done looking at those, plus their essential settings, we'll look at the remaining menus of the 654 and what are some essential settings in each of those menus. To review, the 654 has 7 featured applications. And these 7 featured applications offer a flexible and comprehensive snowmelt control solution. The 654 has 7 featured applications to offer the most flexible and comprehensive snowmelt control solution. The applications are as follows. We have a single zone with boiler, a single zone with boiler and tandem snow ice detection, a single zone with modulating steam valve, a single zone with space heating and DHW. So in this case, the 654 will be part of a larger control solution. And then we come into our multi-zone applications, where we have a multi-zone with a boiler and mixing, multi-zone car wash application, and multi-zone electric. Before we get into the applications themselves, I do want to go over a couple of the essential settings so that they're familiar to you when we look at the applications. The first one I'll draw your attention to is application mode. So application mode must be configured for every 654. And there are 5 different application modes for you to choose from. We'll start at the bottom and we'll work our way up. We have application mode 090. And you would select this application mode if and only if you are doing tandem snow ice detection and you are programming the member 654. So as soon as you enter application mode 090, that control will automatically become the member. Application mode elect is if your heat source is electric heating cables. And in this case, the control would operate the heat relay on a 20-minute cycle with a calculated on time. Application mode mix is selected if the 654 is operating a mixing device, and your options for that are the 0 to 10 volt DC or the 4 to 20 milliamp analog output to operate the mixing device. In this case, the system is going to operate to maintain the calculated mix target. Application mode boil is selected if the 654 is operating a dedicated boiler, and the system will operate to maintain that calculated boiler target. Lastly, we have application mode PWM. Now, one way to remember that is if it doesn't fit any of these 4 application modes, then you can select application mode PWM, or you can think of it as if it's a non-dedicated boiler that's being operated. So perhaps it's a multi-zone snowmelt system. Perhaps there's snowmelt and other heating going on in your system, and you just have the non-dedicated boiler serving all aspects. Then you could select PWM. The control will operate the heat relay on a 20-minute cycle with a calculated on time. If you select application mode boil, you will have to enter what type of boiler you're operating. Is it a modulating boiler? A single stage on-off boiler? Are you connecting the 654 to a TechMar boiler staging control using that EMS1 output? Is the 654 operating a Viessmann modulating boiler? Then you can use the EMS2 output. You can also select control, and you would select control if the 654 is connected to a TechMarnet system control that is operating the boiler. Lastly, we have enable. You would choose enable when the application mode is set to mix and the snowmelt system has a non-dedicated boiler plant. In this case, we would not be using TechMarnet communication, and we would use the enable boiler type. And what would happen with that is the heat relay would close whenever the mixing device was increasing and reached a position or speed of 10%. Likewise, the heat relay will open when the mixing device is decreasing and reaches a position or speed of 5%. So in this case, the time when the heat relay is closed depends on the position of the mixing device. The last thing I want to draw your attention to before we dive into those application diagrams is the auxiliary relay. So the auxiliary relay can be set to operate a system pump or an alert device. If we connect or select it to operate a system pump, then we require the use of an isolation relay. And that is, of course, because the auxiliary relay is tied to the 24-volt R. And of course, we need line voltage to operate our pumps. So we're going to use the isolation relay, and that in turn will allow the pump to operate on the 120-volt circuit whenever that auxiliary relay closes. On the other side, we can connect the auxiliary relay to some optional alert equipment. And we can use that equipment to maybe generate a sound, or for more advanced alert equipment, it could even send a notification to us through email that something is wrong on our snowmelt system. So you would set up the auxiliary relay to operate either as an alert or as a system pump. If it's set up as a system pump, then that relay will be closed continuously during the melt, idle, or storm operation. If you are connecting it to the alert equipment and set it up as an alert function, then that relay will only close when there is a local error. So let's revisit our applications. We have application 1, our single zone with a boiler. Now here we have the 654. It is sending the modulating output to our boiler as well as an enable signal. And we'll look at it closely on the following slide. If we need an enable for our boiler, then we do need to use the isolation relay, and that is because the heat relay is tied to the 24-volt R. The 654 is operating a system pump, and again we require the use of an isolation relay here because the auxiliary relay is connected to the 24-volt R, and of course we need 120-volt for our system pump. Remember, once we set that auxiliary relay up to system pump, this pump is going to operate continuously whenever we're in melt, idle, or storm. We have our boiler supply sensor going to our 654, and we have our optional sensor devices on the right-hand side. So option 1 is the snow ice sensor 090 or 094, and that will give us the automatic start and automatic stop. Option 2 is the snow sensor 095, and that will operate together with the slab sensor 072 or 073. Now we combine those two as option 2 because we want to make sure that we have slab temperature control. Remember, if we're only using the 095, we will have the automatic start and time stop. However, we have no way of sensing the temperature of the slab. So we combine that with the slab sensor so that we do get that slab temperature control as well. Option 3 is to go strictly with the slab sensor 072 or 073, and in that case you would have to operate the 654 manually. Now let's take a look at our electrical. We'll start on the left-hand side. You can see we do have power from our transformer coming into the R and the C. The R is of course tied to the heat and the auxiliary relay. So our heat relay is being used as a boiler enable for our modulating boiler. And we need that isolation relay because we want a dry contact for the TT. So we will connect the heat relay to 7 on our isolation relay 003, and then we have 2 coming back up to our common. So whenever that heat relay closes, we are going to have the TT enable at our modulating boiler. We also have the modulating output mod plus, and minus, going over to our modulating boiler to provide the modulating signal. Our auxiliary relay is being used to operate a system pump. Now that does require the isolation relay 003 so that we can have 120 volts going to our pump. So we have R coming in from the transformer. We have a wire from our auxiliary relay coming over to 7 on the isolation relay, and then 2 is going back to C on the transformer. And then whenever that auxiliary relay closes, we will have 120 volt going to our pump, and our pump in turn connected to ground and neutral. We've shown here the connection to an optional TN4 device. That could be a user switch. And then moving over to our sensor connections, we've shown you some options. So we can connect to the snow sensor 095 plus adding the slab sensor 072 or 073 for that slab temperature control. Or you could connect to the snow ice sensor 090 or 094. So we show both of those sensor connections. We also show the supply sensor 082 and the connection to the outdoor sensor. So taking a look at our essential settings, application mode is boil. We are operating a boiler. What type of boiler? It is a modulating boiler. What is our auxiliary relay doing? It's operating the system pump. So those are our 3 essential settings. Application 2 shows our single zone where we are operating a boiler and where we're also doing tandem snow ice detection. So we have our member 654 and our master 654. The member 654 is connected to its own snow ice sensor 090 or 094, and it's connected to the master 654. The master is also connected to its own snow ice sensor 090 or 094, and the master is also operating the system pump and the modulating boiler. Now, because our modulating boiler requires an enable, we are showing the use of the isolation relay 003, and again another isolation relay 003 to operate the system pump. We have the outdoor sensor going to the master control as well as the boiler supply sensor. One note here is the member 654 can only receive the input from the snow ice sensor 090 or 094. The rest of its relays are not in use. As soon as that application mode 090 is selected, none of the relays can be used for any other purpose. So we are restricted to the input from our sensor and the TechMarnet communication to the master. Taking a look at the electrical diagrams, our master 654 is connected to the system pump through the isolation relay 003. So just like before, we have the R coming in from the transformer, and then we have a wire coming from our auxiliary relay to our isolation relay, which in turn comes back to the C at the transformer. So whenever that auxiliary relay closes, we will operate the pump with the 120 volt line voltage. Our pump will in turn be connected to ground and neutral. Our heat relay will be providing the enable signal to our boiler. Now, because that heat relay is tied to the R, we require the isolation relay. Whenever that heat relay closes, it's going to energize this relay, which will provide the enable signal to the TT. We're of course also connecting this boiler to the mod output from the 654. And our TN4 and C terminals will be connected to the member 654. So that sensor information of the snow ice sensor 090 or 094 is connected to the master through this TN4 communication. You'll notice that we are not connecting anything else to the relays here. There's nothing connected to the heat relay, nothing connected to the auxiliary relay. Because as soon as we select application mode 090 for the member 654, we lose the use of these relays. So someone asked the other day if they could do this tandem snow ice detection and then connect an alert device to the auxiliary relay. And the answer is of course no, because we've lost the use of that relay through selecting application mode 090. The master 654 is connected to its own snow ice sensor. It also has the boiler supply sensor and the outdoor sensor connected. The essential settings for this application, starting with the master 654. The master is the one that's operating the boiler, so the application mode is boil. What type of boiler? It's a modulating boiler. And in this case, the auxiliary relay is being used to operate the system pump. The only setting for the member 654 is that it is application mode 090. That is the only essential setting for the member 654. Application 3 features a single zone with a modulating steam valve. So here you can see we are controlling a steam valve, and we're doing that by using the modulating output on the 654. So that would be using the 0 to 10 volt DC or 4 to 20 milliamp signal. We're also operating a system pump, and if you remember, to control a pump we need to use the isolation relay 003 in order to bring that line voltage to the pump. We have our mix supply sensor going to the 654 so that we can appropriately control the modulating steam valve. And we have our sensor options. Option 1, which is the snow ice sensor 090 or 094. Option 2, which would be our new snow sensor 095 with a slab sensor 072 or 073. And option 3, which is just the slab sensor on its own. Notice here we are not operating a boiler. In this case, we're using district steam. You could be using a steam boiler, but another control would be operating that boiler, not the 654. This slide is showing the electrical diagram for application 3. We have power coming in from our transformer, C and R. The R is tied to the auxiliary relay, and we're using the auxiliary relay to operate the system pump. We will connect a wire from that relay to an isolation relay and tie that back to C at our transformer. So whenever that auxiliary relay closes, we will get line voltage to our pump, and our pump in turn is connected to ground and neutral. We've also shown here the TN4 and C connection for an optional TechBarnet device. So we could connect to a gateway or perhaps a user switch, whatever we'd like to. We've shown it as optional so you know that this is a possibility for this application. We're using our modulating output, plus and minus, to operate the modulating steam valve. On the right hand side you can see our sensor connections. So we have the two options shown here. The snow sensor 095 together with the slab sensor 072 or 073, or our snow ice sensor 090 or 094. We've also shown the connection from the outdoor sensor to the 654 and the supply sensor to the 654. Now in this case, the supply sensor, as you can see here, is for the mix supply. The essential settings, our application mode is mix. We are using that modulating output to operate a mixing device, so we need to select the application mode mix. Our boil type is off. We are not operating a boiler in this case. The application that we've shown illustrates district steam application. It could be a steam boiler that is being operated by another control. Our auxiliary relay is being set to system pump. We are using that relay to operate the system pump. Application 4 shows the 654 as part of a larger control solution. So here, if we look at the overall system, we are doing some space heating and some domestic hot water in addition to our snow melt. We have our 654 that's connected to a wiring center, and the wiring center in turn is connected to a house control. So the house control would be operating the boiler, the domestic hot water, and the space heating. So I'm going to flip to the next slide where we have faded out everything that the house control is operating. We're not going to show you those connections on the electrical diagram just because it would be overwhelming, and all that information can be found from the installation and operation brochure for any of the house controls. We have left in bold all the equipment that is being controlled by the 654. So we have our system pump 2 that's going to be pumping to our heat exchanger. We have a mixing injection pump from our heat exchanger into our snow melt loop, and then our system pump 1 to operate the snow melt loop. You'll notice system pump 2 is connected to a freeze protection aquastat. And this is to protect the source side of the heat exchanger. This is the water side of the heat exchanger that's susceptible to damage from freezing. So whenever temperatures do approach freezing, we're going to cut power to this pump. Remember, our mixing injection pump has to be one that accepts the 0 to 10 volt DC input. So we don't have the floating action valve output, and we don't have our typical injection pump output on the 654. We are using an analog signal. So you have to make sure that the pump you select is capable of accepting that analog signal. We do have a list of suitable pumps in the installation and operation brochure for the 654. We are showing the mix supply sensor in the snow melt loop. This system pump, which will operate continuously, as will system pump 2, whenever we are in storm, melt, or idle. We show you our 3 sensor options. So we can go with the 090 or 094, the 095, or the 072 and 073. I also want to draw your attention to this boiler return sensor. So in this application, we have chosen to do boiler protection. We are connecting the boiler return sensor to the 654. Now, if you remember, we'll see it on the following slide, but there is a shared terminal for the boiler return sensor and the outdoor sensor. So once we configure that terminal to boiler return sensor, it means we can no longer connect an outdoor sensor to the 654. However, since we are connected in the TechMarNet communication to a house control, the outdoor sensor will be connected to the house control, and that information is communicated to the 654 through TechMarNet communication. Here we're taking a look at the electrical. So we have our 654 connected to a wiring center. So we have power to the 654 that is coming from the TN4 wiring center. So you can see we have C and R connecting to the 654. We have TN4 as well going to the TN4 terminal on the 654. And our heat relay is being used to provide the W to the wiring center. Now here's where it gets a little tricky. We're also going to add a jumper to connect the W from zone 1 to the W at zone 2. And the reason we're going to do that is because we want to operate system pump 1 and system pump 2. So both of those pumps will be enabled whenever that auxiliary relay closes. Okay, so just to go over that one more time, we have TN4, C, and R from our wiring center 316 connecting to the snow melt control 654. The auxiliary relay is coming to provide the W at the wiring center, and we're adding a jumper from the W at zone 1 to the W at zone 2, and we do that so that both system pump 1 and system pump 2 will be enabled when that auxiliary relay closes. You can see we're using the boiler expansion terminals to move from the wiring center 316 to the house control. In this case, we have shown a house control 402. The freeze protection aquastat has been connected in line with our system pump 2, so that whenever that temperature does approach freezing, we will break power to system pump 2. Back at the 654, you can see we're using that modulating output to operate a 0 to 10 volt mixing injection pump. And we have the connections to our sensors. So our typical sensor connections, 090 or 094 is one option. The other option is to use the snow sensor 095, hopefully with the slab sensor 072 or 073. And we have the boiler return sensor going to that shared out boiler return terminal. And when we do that, of course, we have to get the outdoor temperature elsewhere on our TechMarnet system, which can be done since we are connecting to a house control as well. And we also have our mix supply coming into the supply sensor terminal. Essential settings in this case, our application mode is mix. We are operating a mixing device. Our boil type is control. So since we are connecting to a house control, it is the house control that is operating that boiler. Our out and boiler return sensor terminal has been configured for boiler return, so we can do that boiler protection. The auxiliary relay is set to system, so we can operate the system pump. Now when we do that, remember, the auxiliary relay is going to close whenever we're in storm melt or idle state. So we'll have system pump 1 and system pump 2 running whenever we are in the melt, idle, or storm states. And the TN4 system pump is set to off. Now I'll just take you to that previous slide to show you that. This would be our TN4 system pump. We don't need that to be operating for our snow melt call. So that's why we set this TN4 system pump to off. And we're moving on to application 5. In this application, we have a multi-zone system with a boiler and a mixing device. So here we have 2 snow melt zones. Each snow melt zone has its own 654. And we have our 3 sensor options, the 090, 094, 095, and the slab sensor 072 or 073. We have zone 1 pump to bring flow to our snow melt zone 1, and zone 2 pump to bring flow to our snow melt zone 2. Both of those zones have their own supply sensor going to the 654. We have a mix supply sensor. Now that's going to be connected to our reset module, because our reset module is what will be operating the mixing device here. We have flow from the boiler going to a heat exchanger, and you can see this freeze protection aquastat. And we'll look at how that freeze protection aquastat works when we get to the following slide. Here's the electrical diagram for application 5. We have our 2 654, zone 1 and zone 2. Zone 1 654 is connected to zone A1 on our zone manager 336. So we have TN4, C, and R from our 336 coming to TN4, C, and R on the 654. Our heat relay is going to be going to the W for that zone input. Zone 2 is the same. We have TN4, C, and R from the Zone A2 input on the Zone Manager 336 coming over to the 654, TN4, C, and R. And again, the heat relay is connected to the W on that Zone A2 input. Zone A1, whenever that heat relay is closed, will be operating the Zone 1 pump. Likewise, when the heat relay closes on Zone 2, we'll be operating the Zone 2 pump. I want to draw your attention here to the freeze protection aquastat and how it's wired. We have line voltage coming in to the 336, and that line voltage has been jumpered over to provide the zone power for those pumps. The freeze protection aquastat is wired in line with this jumper. It is a normally closed contact, so normally you will have power at Zone 1 and Zone 2, and they will operate whenever those heat relays close for each 654. However, if we do approach temperatures that are near freezing, this normally closed contact will open, and we will not be able to operate the Zone 1 and the Zone 2 pumps. There won't be any power there. Looking at each of those 654s, you can see we have our sensor options, the 090 or 094 sensor, or the snow sensor 095, hopefully together with the slab sensor 072 or 073. And the same is true with the Zone 2 654. Each of those 654s has a supply sensor so that we can see the temperature going to each of those zones. Now our essential settings, it's the same for Zone 1 and Zone 2. The application mode is PWM. Now this is a two-zone system, which is why we are using application mode PWM. You can also select this application mode through process of elimination, as we discussed before. So we're not doing 090 because we're not doing tandem snow ice detection. We're not choosing elect, it's not an electric system. We are not operating a boiler at either of those 654s, so it's not boil. The 654s are not operating a mixing device, so it's not mix, and that leaves PWM. Now, the control, the reset module 422, will be operating the boiler, so that's why we say boiler type is control. And this time the TN4 system pump should be on, and I'll just revisit the electric or the mechanical diagram so we can see why. Here's our TN4 system pump. We of course need that to operate to get heat to our snowmelt system. So this must be on for the snowmelt. That's why we set the TN4 system pump to on this time. You can see here the Zone Manager 336 will be connected to the reset module 422. There just wasn't enough room on this slide to have them both side by side, so we're going to show that on the following slide right now. And here is the reset module 422. That will be operating the boiler pump and the on-off boiler. It's also operating the mixing device. And because it's operating the boiler and the mixing device, we need the boiler sensor and the mix sensor both to be terminating at the reset module 422. We also have our outdoor sensor 070 connected here as well. Coming to application 6, which is our multi-zone car wash application. So you can see here, we are talking about a car wash, and this one has two bays, Zone 1 and Zone 2. Each of those bays has their own 654 snowmelt control. And you can see we've connected the slab sensor 072. We're not showing all the other sensor options. And that's because obviously in a car wash application, we're not worried about automatic start and stop. It's not about snow detection. It's about keeping the slab above freezing during the hours of operation to avoid freezing. So all we need is a slab sensor to control that slab surface temperature. Both of those 654s are connected to a wiring center 316. And the wiring center will operate Zone 1 pump and Zone 2 pump, as well as the system pump. And you can see we have our freeze protection aquastat wired in line with the system pump, so that whenever we approach freezing on the source side, we will cut power to that pump. And here we have the wiring for this application. Zone 1, 654, is connected into the Zone 1 input on the 316. Likewise, we have Zone 2 connected into the Zone 2 input on the 316. Now let's follow these wires. We have R, C, and TN4 from the 316 coming into R, C, and TN4 on the 654. We're using our heat relay for the W call on the 316. Now we'll look at the Zone 2 654. Again, we have R, C, and TN4 coming into R, C, and TN4 on the 654. And again, we have our heat relay coming in for our W on the 316. Now you'll notice we are also using the auxiliary relay from Zone 1 and the auxiliary relay from Zone 2. And that's because we're going to be using the Zone 3 input on the 316 to operate our system pump. Now we want that system pump to operate continuously whenever we are in melting, idle, or storm. So the auxiliary relay from Zone 1 will come into the W on Zone 3, and the auxiliary relay from Zone 2 is also coming into that same W. So that means whenever either one of those 654s is in melting, idling, or storm operation, we are going to be operating this system pump. And you can see the freeze protection aquastat is wired in line with that pump, so when we do approach freezing, we will open this normally closed contact and there will be no power at the system pump. Now Zone 1 would be operating the Zone 1 pump on the 316, and of course Zone 2 will be operating the Zone 2 pump on the 316. Each of these 654s has its own slab sensor, supply sensor, and we have one outdoor sensor connected to Zone 1. There's only a need for one because of course that information will be communicated over the TechMar net to Zone 2. Now let's take a look at our essential settings. Our application mode is PWM, and that holds true for both Zone 1 and Zone 2. Now this is a multi-zone system. That is why we are going to use application mode PWM. You can also use the method of elimination. None of the other application modes fit. But multi-zone systems, we do want to use PWM. And then we're going to be operating the heat relay on a 20-minute PWM cycle with a calculated on time. So the heat relay time is determined by the calculated slab target and by the measured slab temperature reading. We are not operating the boiler in this application, so the boil type for both is off. We are using the auxiliary relay output. So we're going to set the auxiliary relay to system pump, and that will give a continuous closure of that auxiliary relay whenever the 654s are in storm, melt, or idle. So we can operate that system pump continuously during those states. Now we have connected an outdoor sensor to the out boiler return terminal on Zone 1, so we have to specify that yes, we have connected an outdoor sensor. We don't have anything connected to the out boiler return terminal on Zone 2, so we specify that it is off. Coming up to our last application, where we have a multi-zone electric application. Now here we have two zones that we're showing, and of course with the 654 you can always connect up to 12 zones. Each zone has its own 654, and we're showing our sensor options. We have the 090, 094, or the 095, and we're also showing the slab sensor 072 or 073. So we recommend that you use the 090 or 094 when it's possible. You can also combine the slab sensor with the snow sensor 095, and that will give you the slab temperature control plus an automatic start option. Now, because we are not operating any pumps on this system, it's an electric system, we can use our auxiliary relay here to operate an alert device. So that's what we've shown here. Here we have Zone 1 654, and on the other side we have the Zone 2 654. The sensor options are the same for both. We have the snow ice sensor 090 or 094. We have our snow sensor 095 together with the slab sensor 072 or 073, and a third option would be just the slab sensor on its own. Looking at the bottom left-hand side, you can see we have our 24 volts from the electric relay contactor coming into our R on the 654. Likewise, the C is also coming into the C on the 654. Our heat relay is connected to the W on the electric relay contactor. So this heat relay will close to allow for melting depending on the sensor water detection, of course, and our settings that we'll get into in a minute. Since this is not a hydronic system, we can use our auxiliary relay to operate some third-party alert equipment. So here we have our auxiliary relay, which is of course tied to the R, and we have a connection from there to the alert equipment and then back to the C to complete the circuit. You can see we have the outdoor sensor connected to Zone 1 only. There is nothing connected to Zone 2 on the other side, and that's because that outdoor temperature information will be communicated over TechMarNet. Speaking of TechMarNet, that is how the two zones will communicate. You can see we have connections from the C and the TN4 on Zone 1 over to the C and the TN4 on Zone 2. Taking a look at the settings at the bottom of the screen, most of the settings for the Zone 1 654 and the Zone 2 654 are the same. They are both application mode elec, so that's an easy one. This is an electric application. The out or boiler return sensor has been configured for out on Zone 1 and has been configured for off on Zone 2 where there is no sensor input there. Our auxiliary relay has been set to alert for both, and the priority has been set to conditional for both. Now we will get into greater detail on the priority settings later in this presentation. For now, I'll just summarize how the conditional priority works for electric applications. In this case, what we do is make sure only one of those heat relays is closed at any given time. So Zone 1 has priority. The heat relay here will close to allow Zone 1 to begin its melt cycle. When this relay opens, only then can the heat relay for Zone 2 close. And then, of course, when that opens, then Zone 1 can close its heat relay again. So we go back and forth by allowing only one heat relay of any zone on at any given time. And we do that to avoid large instantaneous electrical demands on our system and the associated large surplus charges from our electric utility when that happens. So this conditional priority setting for electric applications is a real benefit to using the 654 for these types of applications. Here are the menus of the 654. You can see there are quite a lot of them. We have the View menu, where we can see the operational data from our system. Set Temp menu, where we can configure our operational temperatures. The Time menu. Schedule menu. The Display menu, where we can customize the home screen of the 654. The Scenes menu. Monitor. Toolbox, Override menu, which is new to a snowmelt control, but you may be familiar with it from the Boiler Control 284. Our System menu, Boiler menu, Mixing menu, TechMarNet menu, and finally the Screen Clean menu. Now we're going to go into discussion of most of these menus. Some of them I will not cover. I think the Time menu, the Schedule menu, Display menu, and Scenes menu are all pretty basic. If you have configured any of the TechMart thermostats or controls, and you're familiar with these menus, and we won't go into them in this training webinar. Just like our Designer Series thermostats, You can navigate through the different menus by pressing and holding this button for 3 seconds, and you can scroll through the list of menus by hitting the next button key. Let's take a closer look at the home screen. Up here you can see we offer dual temperature display. So we can show the outdoor temperature. We can also show the run time or the slab temp, so you can customize what you want this home screen to show you. The status field here is also very useful. So right now it's saying timed, which means it is operating in a timed melt. So that could be from a manual start, or it could be from an automatic start from the 095. Other items that would show there would be if it was in warm weather shutdown or cold weather cutout. Warm, which tells you the slab is currently coming up to melt temperature. Away, if you put it into the away scene. Pending, now this would show if you were in a melt and then the temperature dropped below cold weather cutout, you would see pending on the screen, and it would actually alternate between pending and cold weather cutout to tell you it will return to that melt sequence once the temperature rises above that cold weather cutout. We have the wait, and the wait would show up if we are waiting for that zone to operate due to your priority setting. We have sensor, and that would appear if you are using the Tandem snow ice detection function. And track, if this 654 is tracking the operating time of the zone that has the automatic snow ice sensor 090 or 094, then the word track would show up on the screen. So this status field is very helpful to tell you at a glance what is happening in this snow melt zone. We have the operation field. So this will tell us what the snow melt state is. Is it melt, idle, storm, or off? And actually, if you touch that operation field, it'll immediately take you into the view menu. So that's very convenient as well. We have our away scene. So if you know you're going to be leaving for vacation, you can just touch the going away button here, and then the system will no longer respond to any calls for snow melting. And we have the keys that you're familiar with here. So this will show up as stop since we're melting. If we were not in melting, it would show up as melt. So that would be for your manual operation to turn the melt on or off. We have the up and down arrows and the next item arrow. So that is for navigating through each of the menus setting by setting. You can see we also show heat on, just like our Designer Series thermostats. So since it's in melt, the heat is on. This heat on would also show up in the idle and the storm states. And we have our TechMarNet arrows, and we have the exclamation symbol, which will appear whenever there is an error on the system. We're going to start with the View menu, and we'll just look at all of the items that can be seen in this View menu. So the first thing that you can look at is the snow zone. What snow zone is this 654 operating? And we can have up to 12 snow zones. Then it'll show us the slab target if it is currently in the melt, idle, or storm state. We get to see what the current slab temperature is. It also shows us the state of the water sensor. So this would be the 090 or 094. It'll show up as wet or dry. We can see our boiler target and our mix target, our supply temperature, our boiler return temperature, our mix rate. So what position is our mixing device in? We can look at our heat rate. The boiler relay, is that open or close? The PWM rate. The system pump relay, is that closed? Is the system pump operating? Manual runtime and additional runtime. So if it has been manually operated, then In the View menu, you can see how much time is left for that melt cycle. Same with the additional runtime. If it was an automatic melt, then you would see here how much time is remaining for your add melt time. Now just to mention for the relays, the boiler relay and the system pump relay, this will show as off or on. Now I mentioned here this only shows what the control thinks the relay should be doing, so we can't use that to test for a stuck relay. And the PWM rate might need a little bit of an explanation. That is the current duty cycle rate of the zone or the boiler for each of those 20-minute cycles. So the View menu has a lot of information here, and some of it is particularly useful. I think the water sensor information is very useful to let us know if that sensor is working the way we expect it to. Taking a look at the Set Temp menu. This menu is where you will enter your set points, your run times, and the water sensitivity. And we'll talk about all of those over the next few slides. So the set points that you enter here are the warm weather shutdown, cold weather cutout, and your melting, storm, and idling temperatures. So the storm and idling both have a very large range, 20 to 95 degrees. Our default here is off. And melting goes from 32 to 95, and our default is 36 degrees Fahrenheit. That's a good melt temperature. There are two runtimes that can be configured in the Set Temp menu. The first one is manual runtime, and that's the amount of time that you would like the melt cycle to last after you've manually started your snow melt system. The range here is 30 minutes all the way to 24 hours. So you can customize how long you would like your manually enabled melt to last for. You will also input your additional melt time here, and that's if you're using a 090 or 094. So the additional melt time is the time the melt cycle will continue to run after the sensor is dry. So in the image we've shown here, you can see there is no snow on the sensor. The sensor is dry at this point. However, there is still some snow on the slab. So to avoid stopping the melt cycle when there is still that snow remaining somewhere on the slab, what we can do is configure an additional melt time. So the length of time the melt cycle will continue to run after the sensor is dry. And here our configuration lasts from 30 minutes to 6 hours. You will also customize the water sensitivity if you're using the 090 or 094, and that would be to account for pollution or impurities. So you can see there are 7 separate manual sensitivity settings that you can select. And you can also choose the auto setting. And in the auto setting, the control will automatically adjust the sensitivity used to detect moisture. So because we have all of these options here, it is very easy for you to customize the operation of the sensor and the control to your particular area and to the conditions of the snow in your area. So a bit of background on the water sensitivity setting. Sensitivity compensates for the varying outdoor conditions that affect how the 090 or the 094 interprets the presence of moisture. So the control is constantly measuring the resistance across the rings on the surface of the sensor. And the melting snow causes a drop in this resistance. If the snow is very clean, there is a very little drop in resistance. So in this situation, you want the highest sensitivity. If the snow is very dirty, there is a very large drop in resistance. And in this situation, you want it to be set for a low sensitivity. So we show here, mid is the halfway mark. The cleaner the snow is, the more sensitive you should set this water sensitivity to. You can do +1, +2, or max, which is most sensitive. If there's dirty snow, you want it less sensitive. So you can do -1, -2, or min, which is our least sensitive setting. You can also choose the auto setting. In the auto setting, the control automatically adjusts the sensitivity level used to detect moisture. So a lot of options here for you to customize the water sensitivity to your particular region and weather conditions. The Monitor menu contains a lot of useful information for you to determine how your system has been performing. It will tell you the amount of hours that heat relay has been closed and the number of heat cycles that it has seen. You can look at how many hours your system pump has been running. And then you can look at some trends. What was your highest slab temp and what was your lowest slab temp? Likewise for outdoor temperature, supply temperature, and return temperature. So this can be very useful for you to determine if your system is performing the way you expect it to or the way you want it to. Next we have the Toolbox menu, which is a familiar menu for those of you who are familiar with TechMar controls. In this Toolbox menu, you can set your access level. So if you lower the access level, then you can prevent users from changing some of those installer settings. This is also where you can find your software version, where you can load factory defaults, and where you can find the error history. So the last 5 errors will be stored in the error history so that you can see what kinds of errors, if any, your system has experienced. The boiler menu is where you will configure your boiler type. So we looked at early in this presentation the different boiler types that are possible, and we'll revisit that in a minute. It's also where you will put in what modulation type. Is it 0 to 10 or 4 to 20? You can specify the minimum modulation and if there is a modulation delay for your boiler. You will also enter the boiler motor speed, the boiler differential, and the boiler minimum if there is one for your boiler. There are 6 different boiler type settings. You can configure it for mod to operate a modulating boiler, 1 stage for a single stage on-off boiler, EMS1 output if you want to connect to a TechMar boiler staging control. So you could use this output and go from the 654 to a 275, for example. EMS2 if you're trying to operate a Viessmann modulating boiler. Control if the 654 is connected to a TechMar system control and it is that system control that is operating the boiler. And you can use enable. Now enable is for when you select application mode mix and you are not using TechMar communication. So in this instance the heat relay will close whenever the mixing device is increasing and reaches a position or speed of 10%. The heat relay is going to open when the mixing device decreases and reaches a position or speed of 5%. And on the left-hand side, we're showing you the wiring for these different boiler type configurations. If you're using mod EMS1 or EMS2, you're going to be using the mod plus and minus terminals. If you're connected to a TechMar system control, you'll use the TN4 and C terminals out to the TN4 system control. And if we're doing enable or a single stage on-off boiler, then we're going to use the heat relay, and because that is tied to the R, we would bring the heat relay and we'd have to reconnect to the C to complete that circuit. Now if this connection is going to a TT on a boiler, then you would want a dry contact. You don't want the heat relay tied to that 24 volt R. So as we've discussed earlier, you would need to use an isolation relay to provide you with that dry contact closure. The next menu we'll look at is the system menu. And in this menu, you will choose your application mode. You will choose your snow ice sensor. So you will select here if you're using an 090 or if you're using an 095. You will also specify whether or not you have a slab sensor in your system. You can turn slab protection on or off. You will configure that shared outdoor or boiler return sensor input for either the outdoor or the return sensor. You can choose to do economelt, and we'll talk about that in a couple slides. You will also specify whether or not you need the TechMar system pump to operate during snowmelt. You will specify if your auxiliary relay is operating a system pump or if it is operating an alert device. And you can specify your melt time max. So we talked about the application mode already. We'll revisit this. There are 5 different application modes. We have application mode 090. And this is only if you're doing tandem snow ice detection and you are configuring the member 654. We have application mode elect, and that is only if you are using electric heating cables for your snowmelt system. If you do choose this, then you're going to be using the heat relay, and the heat relay will operate on a 20-minute PWM cycle with a calculated on time. And that on time, of course, depends on the slab target and what the current measured slab temperature is. Mix if the 654 is operating a mixing device. Boil if the 654 is operating a dedicated boiler. And PWM is if we have a non-dedicated boiler. So this can be for multi-zone systems. And in this case, again, the heat relay is going to be operating on a 20-minute PWM cycle with a calculated on time that depends on the slab target and the slab temperature. So application mode 090 allows for the tandem snow ice detection functionality. So here we have a single snow zone. And in that single snow zone, we're using 2 090 or 094s. So this is very helpful in large snowmelt zones. If you have a very long driveway or another very large snowmelt zone, then it's difficult to get reliable information from a single sensor that would apply to the entire slab surface. So this is a way of having 2 different sensors in 2 different locations so we can more reliably detect the conditions of the slab as a whole. Each 654 is connected to its own 090 or 094, and we have the Snow Zone 1 member and the Snow Zone 1 master. When you select application mode 090, this control automatically becomes the member control. Now for the master control, you can choose application mode PWM, boil, mix, or elect, depending on what your system is. It is the master that's going to be operating the snow melting equipment. So whether that's the mixing device, the pump, the boiler, only the master is operating that equipment. The member is only connected to its sensor and then connected to the master through the TechMarnet communication. Both of these sensors must be dry for a melt cycle to stop. However, a single sensor that detects moisture can trigger the melt cycle to begin. Both of the slab temperatures are used, so the master control is going to average the slab temperature of both of those slab sensors. So tandem snow ice detection is a great way to get reliable and effective snow detection for a large snowmelt zone, and it's a great way to have redundancy so that if one of those sensors fail, then you are never without at least one sensor that can operate your snowmelt system. Slab protection is a feature that you can turn on or off in the system menu. Now the reason you would want to enable slab protection is to protect your slab surface. What happens when you send very hot supply temperature for snow melting to a very cold slab, like in startup conditions, you can create a thermal shock at the slab. And thermal shock can result in tensile stresses. So you can see these yellow arrows and they're pulling apart in opposite directions of the slab. Now that will result in cracking on the slab surface. To avoid that, you can turn slab protection on in the system menu, and that's going to set an upper limit for that supply temperature based on the current slab temperature. In the system menu is also where you can configure whether the shared sensor input terminal is for an outdoor sensor or a boiler return sensor. So you can see it's this terminal right here. We can either connect to an outdoor sensor or a boiler return sensor, but not both. So in applications like what we've shown here, where we do want boiler return protection, we have this boiler return sensor connected to the 654. What that means is we can no longer connect the outdoor sensor to this 654. but we still need that outdoor temperature. It means we have to get that outdoor temperature from somewhere else. So we've shown a couple options here. One could be by connecting the 654 to a system control. So it could be a house control, a boiler control, or a reset module. And the outdoor sensor is attached to the system control, and the outdoor temperature is communicated to the 654 through TechMarNet. We've also shown another 654. So in a multi-zone system where you have a number of 654s, the outdoor sensor needs only to be connected to one of them, and it will communicate that information to all others over the TechMarNet communication. So in the system menu, this is where you will set it up if that terminal is connected to an outdoor sensor or a boiler return sensor. EconoMelt is a new feature in the 654. We jokingly referred to this in-house as the shovel and melt option. So this is only for when you are using a snow ice sensor 090 or 094. So you do have that automatic operation. But maybe you still want to control your melt cycle. You can select EconoMelt to be on. And what happens if you select EconoMelt to be on is that the melt cycle will not start automatically. So the control will wait for you to manually enable it. And this allows you to go outside and shovel or snowblow your walkway or pathway or driveway. And in so doing, you will reduce your operational costs. So it gives you that option to have the automatic operation, or maybe there are times when, you know what, you are more conscious of your operational costs in your snowmelt system and you want to reduce those costs by shoveling first and then using the snowmelt system simply to remove that thin layer of snow or ice that remains on the driveway after a shovel. So in the system menu, the default for EconoMelt is off. So that means by default you do have the automatic start and the automatic stop. If you change that, so you select EconoMelt on, you no longer have the automatic start. The control will wait for you to manually enable the snowmelt system. However, you still benefit from the automatic stop. So you'll still be using your sensor to provide that automatic stop when the sensor is dry and the add melt time has expired. Advantages to that are the system, it does not stay on for longer than it has to. It's not stopping too early, but it gives you some control over your operational costs by providing that option of shoveling before you start your snowmelt system. In the system menu is where we configure whether the TechMarNet system pump should operate for snowmelt or not. So I have two images here. If we start by looking at the left-hand side, here is my pump to the snowmelt system, and here is my TN system pump. I don't need this pump to operate in order to get flow to my snowmelt system. So in the system menu, I would set the TN system pump to off. If I go to the right-hand side, I have another application where this is my TN system pump and this is the pump to my snowmelt system. In this situation, I do need this pump to operate to get heat to the snowmelt. This is going to bring the flow past the heat exchanger so I can get the heat out to the snowmelt system. So in this case, in the system menu, I will make sure the TN system pump is set to on. We discussed previously how the auxiliary relay can operate a system pump or it can operate some optional alert equipment. So here we have shown both. On the left-hand side, we can see we have configured the auxiliary relay to operate the system pump. So we have R and C coming from the transformer. The R is tied to this auxiliary relay. Now, this is 24 volts. Obviously, for my pump, I need line voltage. So I'm going to use the isolation relay. The auxiliary relay will enable this isolation relay, and then I'll bring the other side back to C to complete that circuit. And then whenever that auxiliary relay closes, I'm going to have line voltage going to my system pump. And from there, I will bring connections to neutral and to ground. Now on the other side, I can set it to operate an alert device. So again, I have R and C. For my transformer, the R is tied to the auxiliary relay, which will enable my alert equipment, and then I'm coming back to the C to complete the circuit. When you set it up for system pump, this auxiliary relay will be closed whenever we're in storm, idle, or melt. So that pump will run continuously to bring continuous flow to the snow melt system when we are in storm, melt, or idle. If you configure that auxiliary relay for alert, then this auxiliary relay will close only when there is a local error on the 654. I think you'll really love the override menu in the Snow Melt Control 654. What this does is it allows you to commission and test your snow melt system when you need to and how you need to. Unlike previous snow melt controls, we don't have to trick the system into thinking it's cold enough to snow or that there's moisture on the sensor. We can use the override menu to operate equipment such as pumps and boilers or the electric contactors when we need to for the amount of time that we need to. So we'll look at each of these 6 different manual override modes on the next slide. These are your 6 manual override modes. We have the mode auto, and that is just operating your snow melt system normally. We have the mode purge for hydronic systems, and this will operate the pumps for up to 72 hours. So this is great at system startup when you want to bleed the system of air. You can use the purge manual override mode. Now the purge time, I said up to 72 hours. You can actually configure the amount of time that you want it to run for. The range is 10 minutes to 72 hours. Max is like max heat in our previous controls, so this would obviously only apply to hydronic systems. You would maintain a boiler or a mix supply of 130 degrees in the max override mode. So if you're in application mode boil, your boiler supply would be targeted at 130. If you're in application mode mix, your mix supply would be targeted at 130. If you are in application mode PWM, then instead we will close the heat relay. So max is also configurable as far as time is concerned. The range is the same as purge. You can go from 10 minutes to 72 hours. Test is for electric systems, and you can operate your electric equipment for 10 minutes using the test manual override mode. We'll talk about hand some more on the following slide, but hand is a way to test individual pieces of equipment. And then the manual override off will disable your snow melting system. So you don't have to cut power to the control. You can just go into your override menu and set the mode to off. Now let's look at the hand mode on the following slide. In the hand mode, you can operate individual pieces of equipment. So you can operate your system pump, and that would be using the auxiliary relay. Of course, this only applies if you've configured your auxiliary relay for system pump. You can also operate the heat relay individually. You can select a boiler percent modulation to test your modulating boiler, as well as a mix percent modulation to test your mixing device. So this is very useful, the hand mode, so that you can maybe isolate potential problems or confirm that every piece of equipment in your system is operating the way you expect it to. Now we come to the mixing menu. Now this is going to configure your mixing device if you are using one. Remember, with the 654, we are using an analog signal. So we can select 0 to 10 volt DC or 4 to 20 milliamp. So this is a departure from previous snow melting controls. We are not using floating action. We are not using variable speed injection. We are using the analog 0 to 10 volt or 4 to 20 milliamp signal. So in this menu, you select your mix type, your motor speed, and your mix max. One thing I do want to mention is that Tecmar will be releasing an actuator motor 742 sometime this summer, and that will accept the 0 to 10 volt signal. So we will have an actuating motor that will be compatible with the 654. In the installation and operation brochure for the 654, we also have a list of pumps from Taco and Grundfos that do use this analog signal. So we have some recommendations for you there as well. The Temp Menu is where you will configure which snow zone this control is operating, so we can have 1 to 12. You will also tell it if it's tracking zone 1. So we have the option of installing a single 090 or 094 automatic snow ice sensor, and that would be in zone 1. Now all remaining zones could simply track the operation of the zone that has the automatic snow ice sensor. This is where you would also configure if it's in a melt group and a storm group. So is it sharing priority with some other zones and you want them to be enabled at the same time by putting them in the same melt group or the same storm group? This is also where you're going to specify the priority setting for your zones. So to review the concept of snow zones, here I have an image where I'm showing 4 zones. I have my driveway at zone 1, my front walkway is zone 2, my side walkway is zone 3, and my patio is zone 4. Now typically Zone 1 and Zone 2 in this type of scenario would be my higher priority zones. So I want to make sure if it's snowing my driveway is clear and that my front walkway is clear. My side walkway will probably be at a lower priority. Same with my back patio. So revisiting the concept of melt groups and storm groups, these 2 zones would probably be in the same melt group or storm group so that you could enable Zone 1 and Zone 2 to operate at any given time. Now you might want to put Zone 3 and Zone 4 in a melt and storm group as well if they share the same priority. Or maybe 3 has a higher priority than 4, or maybe 4 has a higher priority than 3. You can configure all of this by selecting different melt groups and storm groups, and we'll look at that some more on the following slides. Well, the nice thing about the 654 is that we have developed what we call melt groups and storm groups. So if you can remember my earlier example of a multi-zone system where I had a driveway and a front walkway along with a side pathway and a patio. And in my system, the driveway and the front walkway were high priority areas. If it's snowing, I want to make sure my driveway and my front walkway are safe, so I want to melt snow there first. My side walkway and my patio are lower priority items. They're nice to haves. So I can separate those zones into different storm groups. And this is what it would look like on a user switch. I'd have storm group 1, storm group 2, and away. Now when I program my 654s, I can set up zone 1 to be a part of storm group 1, and I can set up snow zone 2 to also be part of storm group 1. And that way whenever I press the storm group 1 button on my user switch, it will trigger the storm operation for zones 1 and zone 2 only. So you can see there, zone 3 and zone 4 remain off. I can do the same thing for those zones though. I can program each of those 654s to be part of storm group 2. And then if I were to push the storm group 2 button on the user switch, both zone 3 and zone 4 would begin the storm operation. If I were to push storm group 2, then zone 3 and zone 4 would also begin the storm operation. I can do the very same thing for melt groups. I could put zone 1 and zone 2 into a melt group, and zone 3 and zone 4 into their own melt group as well. And then I would add another user switch that would have melt group 1, melt group 2. So this is a great added feature that increases the functionality of the snowmelt system by making it even more user-friendly so that you can operate your zones as you want to operate them based on the priority of snowmelting for those areas. Zone tracking, as I mentioned, is a way to install a single snow ice sensor in Zone 1 and have Zone 2, 3, and 4 track the operation of Zone 1. So Zone 1 will start the melt cycle and end the melt cycle when it's dry. Now Zone 2, 3, and 4 will share that total melt time. So when Zone 2 operates, it will have the exact same run time for the melt cycle as Zone 1 did. Same with Zone 3 and same with Zone 4. Now you can customize the additional melt time for each of those zones. So let's say Zone 1 that has the automatic snow ice sensor operates for 4 hours. And then the add melt time for Zone 1 is 1 hour. Zone 2 will have that 4-hour melt cycle, but we can program a separate add melt time for Zone 2. So maybe Zone 2 only needs 30 minutes of additional melt time. I can do that. I can also program individual add melt times for Zone 3 and Zone 4. So you share the operation of Zone 1, but you can customize the add melt time for each of those zones. Now in the Temp menu, you would put the track Zone 2 on for Zone 2, 3, and 4 in this case. So any zones that you want to have track Zone 1, you will turn track zone on. Now, you may want to ask, can I have the sensor anywhere else? Could it be in Zone 2 or Zone 3 or Zone 4? No, it has to be in Zone 1. So all the other zones will be tracking Zone 1. Zone priority is something we need to configure when we're talking about these multi-zone systems. And we need to specify zone priority because our heat source may not have enough capacity to enter into melt cycles for all of our zones simultaneously. So zone priority is a way of customizing the operation of the snowmelt for multi-zone systems depending on the capacity of the heat source. Now we have 3 levels. Those levels are full, conditional, and none. And we'll look at those on the next slide. Here are the 3 different zone priorities that you can select based on the capacity of your heat source. We'll start on the left-hand side with priority equals full. So this is what you would choose if your heat source was only sized for Zone 1 at design conditions. So Zone 1 would begin its melt cycle and end its melt cycle before Zone 2 could begin its melt cycle. So with this type of priority setting, we're going to go through zone by zone. There will be no overlap of more than one zone operating at any given time. Moving over to priority equals conditional, this would be the priority setting you would choose if your heat source was sized for greater than Zone 1, but still not large enough for all the zones at design conditions. So in this case, Zone 1 would begin its melt cycle, and when Zone 1 has reached its melt temperature, then Zone 2 could start its melt cycle. So there is some overlap of the zones, but we wait for each zone to come up to its melt temperature before the next zone can begin. And lastly, we have priority equals none. And this would be the setting you would choose if your heat source was sized large enough that you could accommodate all of the zones at the same time at design conditions. So in this case, all the zones can begin the melt cycle at the same time, and they would end at the same time if they had the same add melt times. Now, conditional priority for electric applications is a little bit different. In this case, we're only going to allow one electrical relay to be on at any given time. So you can see here, Zone 1 is going to start melting first. And when this relay cycles off, then Zone 2 relay can come on. However, as soon as zone 1 relay comes back on, the zone 2 relay will turn off. And this is a way to avoid large instantaneous demands on the electric system and subsequent surcharges from your electric utility. The other two priority settings, full and none, also exist for electric applications as well. So if you aren't worried about limiting the on time of your electrical relays, then you can select the priority of none. If you are worried and you want to do zone by zone, then you can select priority of full. Now we've come to the close of our last training session for TechMar's Snowmelt training webinar series. What we covered in this session was our 7 featured applications for the Snowmelt Control 654, and we looked at the mechanical and the electrical diagrams for each of those applications and discussed the essential settings. Then we looked at the other menus of the 654, of the information that can be viewed, and at what we need to program in each of those menus. I hope that you learned a lot about snowmelt systems in general and found this very comprehensive as far as the learning of the new Snowmelt Control 654, as well as how to integrate that with the sensors 090 and 094 for the automatic start and stop, and the new snow sensor 095 that gives you that option to have an automatic start for retrofit applications or scenarios when we forget to install the socket before the concrete is poured. If you have any questions, we'd love to hear them. You can email us at learn@techmarcontrols.com and we'll make sure we get back to you within the same business day. Thank you very much for joining me. My name is Elizabeth Brown and I hope to hear from you soon. Bye-bye.